Mobile devices and client-side virtualization, part 3. In this nugget, we're going to focus on virtualization. Virtualization is when one physical machine hosts multiple activities that are normally done on multiple machines. Two general types of virtualization are server-side virtualization and client-side virtualization. The basic difference between the two is where the virtualizing takes place. Let's see how each can be implemented. Server-side virtualization provides a virtual desktop for users on multiple client machines. Most, if not all, processing is done on the server, which provides to the client the virtual desktop infrastructure. Server-side virtualization provides a virtual desktop for users on multiple client machines. Most processing is done on the server. It also provides a virtual desktop called the VDI. Let's look at the advantages and disadvantages of a server-side virtualization. Advantages is that it maximizes company's investment. In fact, it has one of the lowest investments since all processing takes care in this powerful box, so that you really need to invest only on this single box. It also centralizes support for hardware, software, and the users. The disadvantage, of course, is that high-end servers are required, and of course, having said so, it requires more network bandwidth. User experience with this kind of virtualization software may be diminished because all processing is done on the server side. Using server-side virtualization, three categories of clients might be used based on the computing power of the client. This could be either a fat, thin, or zero client. Fat clients actually has regular desktop or computer laptops install the virtualization software. Thin clients has the computer has the local host, that is, has the regular OS but comparative little computing power. Zero clients, otherwise known as dumb terminals or ultra-thin client, does not have any operating system or processing at all. It's just used to provide user interface, keyboard, mouse, and monitor support. Many small organizations that want to use server-side virtualizations are turning to cloud computing services to reduce the cost of hardware, software, and technical support. Cloud computing is when server-side virtualization is delegated to a third-party service, and the internet is used to connect to servers and client machines. Cloud computing can vary by degree of service provided. It could either be implemented in the form of an infrastructure as a service, where servers and storage for a client is provided as needed, or the entire platform, which provides just the servers and the operating systems, or simply the SaaS or software as a service, which provides the operating systems and the applications required by the client. Using client-side virtualization, a personal computer provides multiple virtual environments. For applications, client-side virtualizations can be implemented using several methods, including these three, which are presented from the least amount of computing done on the client machine to the most computing done on the client machine. So you got the presentation virtualization, application virtualization, or the client-side desktop virtualization. To say, however, that the third option here, which is the client-side desktop virtualization, requires that the client's machine is powerful enough to actually hold the processing requirement and storage requirement needed by the virtualization software. Using presentation virtualization in this diagram, a remote application running on a server is controlled by a local computer. You learn to set up this remote application later on using the remote app and desktop connection tool. The user remotely controls the application running on the server, and the application data is also stored in the server. Both server-side and client-side virtualization can be used to create virtual machines. The VM can exist on the server and be presented to a remote user, which is called the server-side virtualization. Or the VM can be created on the local machine, which is to be used locally, which is known as the client-side virtualization or client-side desktop virtualization. Software to create and manage virtual machines on a server or on a local computer is called a virtual machine manager, otherwise known as a hypervisor. Hypervisor software can be either type 1 or type 2. The differences are diagrammed here in 10-58. A type 1 hypervisor installs on a computer before any operating system and is, therefore, called a bare metal hypervisor. After it installs, it partitions the hardware computing power into multiple VMs. An OS is installed in each VM. Example of Type 1 hypervisors are the Zen servers by Citrix, really powerful and highly recommendable. ESXi by VMware, which is their flagship product, and Hyper-V by Microsoft, which is quite new to the market, but nonetheless quite competent and stable. Most server-side desktop virtualization is done using a Type 1 hypervisor. A Type 2 hypervisor installs in a host operating system as an application, not as an operating system. Virtual PC, VirtualBox, VMware Player are examples of Type 2 hypervisors. A Type 2 hypervisor is not as powerful as Type 1 hypervisor because it is dependent on the host operating system staging the actual application. It is dependent on the host operating system to allot its computing power. A VM in a Type 2 hypervisor is not as secure or as fast as a VM in Type 1 hypervisor. And based on experience, most of my students always experience lots of crashing if they're using a Type 2 hypervisor. Type 2 hypervisors are typically used on desktops and laptops when performance and security are not significant. Let's now look at the hardware requirements offered by these virtualization technologies, starting off with the motherboard IOS. The motherboard BIOS and the processor should support hardware-assisted virtualization, or HAV. For Intel processors, if you go to the BIOS software, you would see this feature called Intel VT, and there's a checkbox in that you have to check it before you can actually load these hypervisors on your operating system. For AMD processors, the technology is called AMD-V. The feature must be enabled in the BIOS setup, like I said. Um, in your textbook figure 10-59, it shows the BIOS setup screen for one motherboard where the feature is called Intel VT. When you enable the feature, also verify that all subcategories under the main category for hardware virtualization is enabled. Processor and memory. All processors sold today support hardware-assisted virtualization. Plan on using these a dual-core processor or better, or if your budget allows it, go to even a quad or even octa-core. The ones that are being offered by AMD, the octa-core, is a very good hypervisor platform. The system needs a lot of memory, remember, when running multiple virtual machines. Some hypervisors tie up all the memory you have configured for a VM from the time the VM is open until the VM is closed, even though the VM is idle. Be aware of that. Remember that the hypervisor emulates the hardware and presents this virtual machine to each VM, so you can actually have your own mouse driver there. You can have your own printer driver. It includes a virtual processor, a virtual memory that is being allocated from the host, a virtual hard drive that's allocated from the host storage device, a virtual optical drive, which is actually a shared optical drive from that of the host, as well as keyboard, mouse, monitor, and network adapter. As well as you can add or remove this peripherals as you deem fit from the hypervisor's main menu. Here's an example of a BIOS setup utility. When setting up a virtual machine, be aware of emulators that might be required by an application or user. A hypervisor emulates hardware and presents this virtual hardware to each VM, which can include a virtual processor, memory, motherboard, hard drive, optical drive, network adapter, even SD cards, USB device, printers, and other peripherals and components. For example, all VMs have a virtual motherboard. When you press a key at startup to access Setup BIOS on the VM under Windows Virtual PC, the BIOS Setup main menu will appear as shown here in Figure 10-60. Using this virtual BIOS setup, you can configure the virtual motherboard and other hardware components in the VM just like your host machine. A hypervisor offers a way to configure each VM, including which virtual hardware is installed. For example, when you launch a virtual PC by Windows, the virtual machine window shown on the left side in Figure 10-61 appears. To configure a VM, select the VM on the right pane and click Settings. The settings box shown on the right side shows up. You can use this box to install and uninstall virtual hard drives and other virtual devices in the VM, including that of memory, processor, even shared folders. Remember, a virtual machine is susceptible to hackers and malwares, just like any physical machine or a host machine. Keep these points in mind when securing the resources in your virtual machine. All right. I hope this has been informative for you, and I would like to thank you for viewing.